hope you all had a great break. So today we are going back to our Unit 3 and continue our conversation about dilation. And also today the focus will be constructing dilation on the coordinate plane. So before that, let's quickly check the dilation we mentioned before. So when we mention dilation, we know it just basically we change the size of the shape. It either becomes larger or smaller. And we use scale factor to describe how large or how small the shape will be changed to. And another word for center dilation, so basically is where we use a point as a starting point to make this change. So today we are going to focus on one example, and please pay attention to the process of how do we complete this dilation, and later you can definitely replay this to make sure you understand all the steps. Okay, so let's check the example. This example said we need to construct a dilation of this triangle KLJ with scale factor of 3. So when we look at numbers 3, I know it's going to become a larger picture, which is called enlargement, right? Because it's greater than 1. And center at point D for 3. So very first step, we need to focus on this center of dilation because as you can see, this point is not on the graph. So the very first thing we are going to label this point on the graph, which is 4, 3. So 1, 2, 3, 4, 1, 2, 3. So it's going to be here. This is our center of dilation. So next is one thing I want you to imagine. So we are going to think about this is the place, this is a location you are going to place a flashlight. So you are going to shed light on this triangle. So a big shadow is going to be around here, right? So you can imagine it's like this way. So this is where you place the flashlight. And then what we are going to do is, as I mentioned before, what we are going to do is we are going to start this point and check how do I move from this point to each vertices, to each vertex. And then we just need to repeat this process as we mentioned for a scale factor 3 times. So let's check how do we do that. From D to J, as you can see, I go up 1, left 2. I'm going to repeat it. So go up 1, left 2. This is the how do I move from the D to J. So I'm going to keep moving like this way. And this is our first time. Okay, this is the first time. So up 1, left 2. Second time, up 1, left 2. Third time. So this is our J prime. Okay, so now let me just continue this step to the other 2 points too. So from D to L is go down 3. So 1, 2, 3. Remember, this is your first move. So it's not like you figure this out and repeat 3 times. This is already your first move. So 1, 2, 3 is 1. 1, 2, 3 is 2. 1, 2, 3. This is our third time. So this is our L prime. So we are going to figure out the last point, which is K. From D to K, you can move whatever the way you want, but you cannot just count it diagonally like this. Either go left 3, down 2, or down 2, left 3. Whatever the way you like. So you can try down 2, left 3. So 1, 2, down 2, 1, 2, 3, left 3. And then 1, 2, 1, 2, 3. Right? So down 2, left 3. This is your second time. Then 1, 2, 1, 2, 3. Okay. So this is our K prime. As you now you see we have 1, 2, 3, 3 points. Now I just need to connect them. So I'm going to, yes, this is going to be fine, and yes. Okay, so it's going to be J prime to K prime, then K prime to L prime, and then L prime to J prime. Okay, now as you can see, this is a enlargement because as you can see, our image is getting larger. So this is how do we construct this dilation on the coordinate plane. And also, please do not forget this factor, scale factor 3 is a keyword here to tell us how many times we need to move. So let's go back to check this two triangle. The very first thing, as we mentioned, after dilation, triangle, these two triangle, what's the relation between these two triangle? Probably some students already figure out the answer. Yes, you are correct. It's similar. They're similar. And also, if we just really pay attention to the two sides, let's say JK and also G prime, K prime. So two, several things we need to pay attention. First of all, these two line segments are parallel because they will never intersect each other. And also for the length, for example, if I say JK is 3 inches, then this will be how long for this? Some students already figure out it's going to be 9 inches, so that means JK times 3. That's how long to J prime, K prime. This 3 is actually coming from, scale factor. 3, it doubles 3 times to get the new image. So that's how long for this, okay? So this is something I want to, share with you today. And there is definitely, so some student might wonder, what if the scale factor is not a whole number? What if this is 1.5 or 2.5? Then how do we figure it out? That's something we are going to explain in the following video tomorrow for a new lesson or the day after tomorrow. So for next lesson, we are going to deal with something like decimal scale factor. But today we focus on like scale factor 2, 3, or 4. So I hope this video is helpful. You can definitely replay it to make sure you understand how do we actually get this triangle. Thank you so much for watching this. See you soon, everyone. Take care.